All right, let's try this again. A really important day. We're going to use this all the time. Okay? Remember your limit definitions. You got those two things. If you ever see h approaching 0, a reminder that that is simply a derivative question. When you see that h approaching 0, it's a derivative. If you see x approaching a number and then x minus that number, it's a derivative. Okay? So again, these are called limit definition problems. They look like limits, but it's really a derivative in disguise. Okay? It's a derivative in disguise. So at first glance, you could plug in 0 and you get 0 over 0. But instead, when you see that h approaching 0 and that h, it's telling you this is a derivative question. So I need to know my function, I need to find its derivative, and I want to find the value. So as we look at this, we see h approaching 0, it's going to set up like this. I need to know what is the function that they're describing here. It normally says f of x plus h. Well, this is e to the x plus h. That 2, they already substituted in for 2. It's really x plus h. And so my function is simply e to the x. That's what f of x is going to be here. And the 2 is going to represent my x value. So I'm going to put that right there. Now we're going to find the derivative. What is the derivative of e to the x? E to the x. Oh, that was hard. The derivative of e is what you see. It's just e to the x. Great. I found my derivative. Now I'm going to find f prime at 2. So what is my derivative going to be? E squared. That's my answer. Okay, because I took 2 and I plugged into my derivative. It's not always that easy, but that's the main idea. Okay, let's try it again. We're going to skip the second one. It's fine, but let's go to the third one. So the limit as x approaches e, natural log of x minus 1 all over x minus e. There should be something here that is telling you that, hey, this is a derivative in disguise. What about this setup is telling you it's a derivative in disguise? Good, I'm hearing it. X approaches e, and then x minus e. Those combination of things is telling me that this is a derivative in disguise. All right, so as soon as I recognize that, I'm like, all right, I got to find a derivative. That means I need to know what my function is. I need to know what the derivative of the function is. And then I'm going to find the derivative at a certain value. So based off of this is the formula that you have here. This is the formula that you have. You know that it looks like this. Talk with your neighbor and figure out what you think f of x is going to be. Talk with your neighbor and think, what do you think f of x is going to be based off of that? What is in the f of x spot of that formula? Natural log of x. Where it said f of x, it says natural log of x. So guess what? F of x is natural log of x. Now we're going to find the derivative of natural log of x. What is the derivative of natural log of x? 1 over x, because 1 over the baby times the derivative of the baby, but the baby's just x, so it'd be 1. So it's just 1 over x. Now I need to find f prime at a value. What value do you think I'm going to use here? It is e, because I'm finding that x approaches c, and that c represents what I'm finding the derivative at. Okay, we did that a couple weeks ago, or a couple months ago. But there's our setup. So my final answer here, 1 over e. 1 over e. They're weird. I just plugged e in for x because it's f prime at x, so I'm plugging in e for x. They're weird, but don't let them be crazy either. Okay, if you're not perfect at this, it's fine. For me, when I was in school, I remember this being the one thing that I was like, I don't get it. But once you recognize what you're doing, once you recognize what f of x is, it's not as bad. Let's look at the next one. Okay, so we're looking at it. Again, we can tell this is a hidden derivative because I got the h approaching 0 concept. Okay, I see that h on bottom, so I know that's going to be part of this as well. So that tells me I need f of x, I need f prime of x, and I need f prime at some value. Go ahead with your neighbor here and solve that question for me. All right, here we go. So again, h approaching 0. You need to memorize the formula a little bit at least. Right here, it normally says f of x plus h minus f of x. So what do we think f of x is in this case? Natural log of x. It's right there. Boom, boom. This is natural log of x. Once I've identified natural log of x, then I'm going to take the derivative of natural log of x. What's the derivative of natural log of x going to be? 1 over x. And then I'm going to find f prime at whatever value it is. What do you think my x value is going to be? Because they told it to me right here. Don't let it be harder than that. They told me that was 2e. Then all I'm doing is plugging in 2e. My answer is 1 over 2e. Questions there?
No, sir.
Do one more. Try that one. Try that last one. Or try the middle one there. See what you can do. All right, here we go. We're finding f of x. We're finding f prime of x. And we're finding f prime at c. So as we look at this thing, again, the key to this problem is this guy right here. X approaches 2, and then x minus 2 on bottom. Okay, so we can tell that it is this form right here. And we know that it's f of x minus f of c. So this is f of x minus f of c. It already set it up. So Jesse, what's f of x going to be? ln of x plus 3. And what's the derivative of that going to be? 1 over x plus 3 times the derivative of x plus 3. But remember, that's just 1. Because x would get me 1 and 3 would go to 0. And then we're finding the derivative at 2. Since I'm approaching 2, my answer is 1 over 5. Questions with those? They're weird. You just got to practice them. I could help you do them, but eventually you just got to rep them. All right. Let's change gears here a little bit. Those are a little bit more conceptual. The next ones here are very straightforward. You got to be good at this. This is really important. Interpreting the meaning. Okay, this is going to be on one of your free response questions. Okay, in May when we take this test, I guarantee this is going to be part of it. Interpret the meaning of a derivative. Okay, a reminder that derivatives are the instantaneous rate of change. That's what a derivative means. Okay, so when they ask you to interpret the meaning of a derivative, it is like a Mad Lib. Okay, you are filling into this sentence. It is always this sentence. Don't change from it. Okay, here's what you're going to write. The blank. In the blank, you are going to say whatever it is you're taking the derivative of. Okay, so whatever they gave you. And we'll make that clear here in a second. But whatever they gave you. If you're finding h prime, well, what does h mean? If they're finding f prime, well, what did f mean? They will tell you in the sentence, f means this. Write that word in there. Okay, so the blank is, in the next blank, we are either writing increasing or decreasing. It's one or the other. It's either going up or it's going down. We're talking about a derivative, so we're going to say at a rate of. Okay, we're talking about that rate that we're given. At a rate of. Right here, we're going to put our number answer, whatever the derivative is. That's where our number is going to go. We're going to include units. And we're going to say at t equals whatever the time is. You have to, the key to this more than anything else is at. Remember, when we talk about derivatives, it's at a single moment in time. It's not over a time period. It's not during some, it's at. Single moment. You got to say at. That's really important. All right, let's do it. A weight that is attached to the end of a spring is pulled and then released. So imagine what you got here. I'm just going to draw you a picture so you see it. Okay, you've got you've got this spring here. You've got a weight. You pull that weight down, you let it go, the height is going to change because it's moving. Okay? The function h gives its height in centimeters after t seconds. What is the best interpretation of h prime of 0 is equal to 3? So we are going to interpret that. Okay? H prime of 0 equals 3. We're interpreting a derivative. So here's what we're going to say. What did they give me? What is h a representative of? The height. The height of the weight. I'm going to go ahead and say of the weight just because it's a little more clear. But the height of the weight, you could just say the height, is what? Thumbs up if you think it's going to be increasing. Thumbs down if you think it's going to be decreasing. Andrew, why do you think it's going to be increasing? Because this 3 is positive. So the height of the weight is increasing at a rate of Now I'm saying at what rate? What rate is it increasing at here? 3, because it says right there, it's h prime at 0 is equal to 3. At a rate of 3, then I got to include units. This is a derivative. You're taking the change with respect to time. So it's 3 what? Centimeters per second, because I'm taking the derivative over time. 3 centimeters per second at, you got to include the word at, t equals 0 seconds. Okay, because h prime at 0 is right there in the middle. This is the time right here. Kind of makes sense with why we did the first one. Do the next one. Due to a tide, the water level rises and falls in Buzzards Bay. D gives the depth of the water in meters. T hours after midnight. What is the best interpretation for the value of the derivative of D at t equals 8 is equal to negative 0.5? Write your answer. It doesn't. So no, we asked this question earlier. No, the unit of the time is not always necessary, but it never hurts you to write it. Like, you're not going to screw that up. It'll be very clear. What'd you write here? Lulu, what you got? Hang on, the depth of water, because what did they give me? They gave me D, which is the depth of water. Okay, D gives us the depth of water. So the depth of water, keep going, is decreasing. How did you know it was decreasing? Because it was negative. Because this is negative right there, she said it was decreasing. Is decreasing. Keep going. At a rate of 0.5, oh, you meant negative 0.5, right? Yeah, negative 0.5 meters per hour. Yeah, I'm a mean person. Don't listen to me. I was mean. We made eye contact. I tricked you. Why don't we want to put negative there? It already says decreasing. Don't double negative that. You were right. I just threw it in there because I'm a mean person. 0.5 meters per hour. Finish it. At t equals 8 hours. Great. One thing I hate that they do, but they do this every once in a while. They'll make this a multiple choice question. Okay, and they'll give you like 4 examples. And one of them will say, at the end of the 8th hour. And that's a really dumb way of saying it, but that's true. It's at the end of that 8th hour when you count it up, because it'd be like 0.5, 0.7, and then 1 hours. And then at the end of the 8th hour would be true as well. But the key there is at. You would not want to say during the 8th hour. Bad. At the end, or at a single moment in time. Everybody good there? All right, flip it over. Let's keep going. I got about 2 left. All right, so this is one I never taught before, but then we get to it and kids miss it. And I don't want you to miss it. This is easy, so don't make it harder than that. We've already done one of these earlier in the year. Estimate the derivative. Okay, this table right here is a table of f. What is our best estimate for f prime at negative 11? We can make based on this table. Okay, our best estimate for f prime we can make on this table. Okay, this is f. I want to talk about f prime. What am I going to look at from f to talk about f prime? The rate of change, otherwise known as the slope. I want to know the slope. That's what I want. I want to know the slope at negative 11. Well, they didn't tell me x is negative 11. So what can I use to help me estimate the slope? The 2 numbers that negative 11 would fall in between. Negative 11 would fall right there. So we're going to pick whatever the 2 values that are the closest to negative 11, that's the 2 we're going to pick. So we're picking these 2 right here. Okay, it gives you 2 ordered pairs. You got the ordered pair, negative 12, comma 7, and negative 9, negative 4. Make sure you're writing that as x and y. These are your x's up here. These are your y's down here. And then to estimate a derivative, all you are doing is finding the slope, which is easy, but I would say about 20% of my kids, when we get to this in May, they'll just screw it up because your brain is fried with 10 other thousand calculus concepts. You're just finding the slope. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Rise over run. Y's over x's. I always get x's over y's. Don't do that. That's not how you find slope. So my answer here is negative 11 over 3. That is the estimate. It's not exact, it's an estimate. Okay? A key thing here is you have to show this step right here. I think this is the meanest point that they could take away from you on the AP exam. If you are estimating slope and you don't show that you use slope formula of some sort, if you don't have a fraction of some sort, you're not going to get points. You need to show that you subtracted in a fraction or added in a fraction to get points. Yes, sir.
Do we need the wavy equal sign to show?
You didn't know that's approximate. No, you don't have to have the cool wavy equal sign. I would suggest it because it is approximate. It is not the actual derivative. We're approximating that. You're welcome. We good to hear? Now let's put it together. Okay, so we just learned two different things. Let's put it together. So the temperature in degrees of an oven being heated is modeled by that function. The table gives the temperature every 4 minutes. Use the data in the table to estimate the instantaneous rate of change of the temperature in the oven is changing at T equals 10. Show the computation that lead to your answer, indicate units of measure, and then I'm going to go ahead and say interpret the meaning. Talk with your neighbor. We just did both of these things. Estimate and then interpret. Include your units. See what you can do. Go. Let's see what we can do. We're trying to interpret at T equals 10. So if we're trying to interpret at T equals 10, Isabella, how did you interpret? What does instantaneous rate of change mean, by the way? The derivative. We're finding the derivative. Good. So we are trying to figure out what is H prime at 10, and we are approximating it with the cool little wavy equal sign. Isabel, what numbers did you use here? Good. These are the two values she's using because 10 would fall in between there. Those are our setup. So we are going to find the derivative. We're going to find the slope. So what did that look like for you? Wonderful. 80 minus 73 all over 12 minus 8. She has to show that fractional setup where she's subtracting. She gets 7 over 4. That's the first part. We didn't interpret it. We didn't show the units yet. Let's interpret that. Okay? So let's go through that. Max H, what did you say for your interpretation here? The temp of the oven. Great. Keep going. Is increasing at a rate of 7 over 4 degrees Celsius per minute. And don't overthink the units here, right? 80 and 73. Oh, those were in degrees Celsius. 4. Oh, that was in minutes. So it's degrees Celsius per minute. Good. At T equals 10 minutes. Lovely. Perfect. Everything about that's great. Okay. We said what it was. We said whether it was increasing or decreasing. We said at a rate of. We said what the thing was with units. And then we also gave the time. And the time is important at T equals 10. One more. Okay. Last question. A little trickier. Be careful on your interpretation here. I gave this one. This is on the 2018 exam. I would say only about 15% of my students got this one right. Okay, so take a second here. Be careful. Be on the lookout for a little bit of a trick and see what you can do. Here we go. You might not be perfect yet, but let's see what we got. Using the data in the table, we're approximating G prime at 3. So if I want to approximate G prime at 3, Max M, what did you do from there? This is G. He's trying to interpret G prime. And so for him to interpret G prime, we are going to find the slope. Good. So how did you set that up? Great. Yep. 5.4 over 4. Cool. Everything about that is good. Now let's do the rest of that. So that's just approximating it. I'm not getting the real answer yet. That's a cool wavy symbol. Okay, we're not going to find the real answer, but we are going to, with correct units, interpret the meaning in context of the problem. Anybody confident in their answer here? Aaron, what you got for us? Hang on, careful with that. So you're close, and this is what everyone does. It's what they gave you. Okay, we're finding G prime. That is the derivative of G. what is G? That somebody just said it. It is the rate at which grain is added. Okay, that is the trick here. It's a little bit funky. Okay, but you're correct. It is the rate at which grain is added, and it's going to matter here in a second. The rate at which grain is added is increasing at a rate of. So this is weird because it is a rate of a rate. That is what's happening. That is what makes this one difficult because you have to recognize that, oh, it's a rate of a rate. At a rate of 5.4 over 4. Then we got to go units here. Be careful because it's a rate of a rate. Cubic feet over, it is minutes squared. Because think about it. Okay, look at G of T. G of T is cubic feet per minute. So it's feet cubed per minute. And then I divided by minutes again. That's why I'm getting that minutes squared because I got dividing by minutes twice. Finish that, Aaron. At T equals 3. Good. That one's with a tricky part. It's a rate of a rate.